Alright, this is a bonus section. We get a little bit of geometry in this section, a little bit more geometry. We've already looked at some topics, but now we're going to speak specifically about angles of triangles. Now there's a very key theorem. By the way, a theorem is a statement that has been proven true, like the Pythagorean theorem. It's not quite as famous as the Pythagorean theorem, but it's a very important theorem that says the sum, or that's what you get when you add, of the measurements of an angle, of the angles of any triangle, it doesn't have to be a right triangle, any kind of triangle, the sum of the measures of the interior angles, this angle here, this angle here, this angle here, the sum of the measures of the interior angles of a triangle is always 180 degrees. Always, always, always. It doesn't matter how tall the triangle is, how skinny it looks, if it's a right triangle or not, it always, always, always adds up to 180 degrees. And this is the symbolism. The measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. This is angle A right here, angle B right here, angle C right here. Okay, if we add up those measures, it always is 180 degrees. Now we can use that to find a missing measure. See, if we know two of the angles, we can find the third. See, this is a right angle, so we know this is, remember, 90 degrees. And this is 45 degrees. I can find the missing angle by adding up the two I know and subtracting from 180, since all three have to add up to 180. So 90 plus 55, that's 145 degrees. Sometimes I forget to put the little degree sign down. So now to find x, x is going to equal 180 minus 145 degrees. Or in this case, that would be 35 degrees. That would be my measure. Over here, I have two of the angles given. I'm trying to find the third one, so I'll add up the two that I know. I'll add 47 degrees plus 49 degrees. I get 96 degrees. And if I subtract from 180, x should be 180 degrees minus 96 degrees, which is 84 degrees. So that's very simple to use, and we can find a missing measure given the other two. Now, one of the other things that I wanted to mention with respect to the angles of a triangle is that sometimes we classify triangles by their angles. I mean, I've already used the term right triangle several times when we were doing the Pythagorean theorem and such, but there are other types of triangles based on their angles. The first one I'm going to mention is an acute triangle. That has three acute angles. Now, if you're not sure what an acute angle is, let me tell you. An acute angle is an angle whose measure is less than 90 degrees. Whose measure is less than 90 degrees. So I would have, for example, this triangle. 47, 49, and 84. All three angles are less than 90 degrees. That's considered an acute triangle. If all three angles are acute, it's considered an acute triangle. A right triangle, well, I don't think I need to tell you that, a right triangle has one right angle. Can't have more than one, because if it had two, that would add up to 180. That wouldn't leave anything for the third angle. It wouldn't be a triangle at all. So a right triangle has one right angle, and then of course the other two angles will be acute. An obtuse triangle has one obtuse angle. Now, an obtuse angle means an angle that's greater than 90 degrees. In fact, between 90 and 180 degrees. Between 90 and 180 degrees. Now, I'm not very good at drawing them, but here would be a good example of an obtuse triangle, because I tried to construct it so that this angle right there was bigger than 90 degrees. That's an obtuse angle. That's an obtuse triangle that it's in. The last one is a very special type of the acute triangle. It's called equal angular triangle, and all three angles are equal in measure, so all three angles equal in measure to be 60 degrees. 60 plus 60 plus 60, of course, equals 180. So if all three angles are 60-degree angles, it's called equal angular. Equal angular is also equivalent to the idea of what we call equilateral, where we know not only are all three angles the same measure, but all three sides will have the same length. So if you hear the expression equal angular triangle, it's the same as an equilateral triangle. Alright, there's some problems for you to be working on that are kind of a bonus. So be sure to work on this and practice, practice, practice.